Hi, my name is Dave Lannom with Monroe Training. Welcome to today's segment on basic meter usage. First, a quick warning. To work on hybrids, you need to be able to diagnose high voltage leaks in cables and internal windings inside the transmission and the inverter. Only a Cat 3 meter can do this. So please don't try to use a standard digital volt ohm meter for diagnosing hybrids. This class is covering a generic overview of an auto-ranging digital voltometer. I'm going to be using one that was basically a $20 meter from Amazon. Always refer to the specific user's manual for your meter for your specific operation. So let's talk about our agenda today. Why are we covering digital voltometers? We'll go through that. We're going to talk about some basic measurements and the overview of the meter. We're going to do a quick demonstration and then I'll summarize. So why are we here today? When you think about this, a diagnosis is the outcome of multiple tests. A diagnosis isn't the test. The diagnosis is the result of the test. If I'm going to follow a testing flow chart frequently, I'll be asked to measure voltage, potential voltage, and voltage drop. If I'm going to test the integrity of a sensor or fuel injector, you may need to measure its resistance. To understand why a fuse is blown or why a resistor or potentiometer is frequently failed, you may need to measure the current and compare that to manufacturer's specifications. A working knowledge of your digital voltometer allows you to provide a faster, more accurate, and timely diagnosis to the guest, reducing diagnostic times and leads it to a faster turnaround and shorter downtime for the guest, improving our guest overall satisfaction. And remember, our satisfied guests refer more friends and more family. So let's start this. First of all, let's get familiar with the basic meter. So we've got a basic meter here. And the first thing I need to know is, okay, where do the leads go? Now, if you take a close look at the meter, you'll see a common port. And the common port functions through all the tests. And that's where my black lead is going to go. Now, if I'm going to measure volts, AC or DC, or resistance measured in an ohms, and I put my red lead in the volt ohms and hertz one. Now, also on the other side, we've got some current functions. There's a high amp current function, and that's where my red lead would go for amperage tests. And remember, when I'm testing for current flow, I'm always going to start with the highest setting first. If we put it in the lowest setting and we've maxed out that lowest setting, we can blow the fuses in the meter, which may become costly, possibly damage the meter. And in the best case, you're still taking the meter apart to put a fuse in. So once I've confirmed that it is truly a low current flow, I can actually get it down to microamps by using the low amp function with the red lead. Anytime that I've measured current flow, as soon as I'm through with that test, always remove the red lead. So here's our basic digital volt ohm meter, and let's go through its settings. So remember, there's other settings that are available on a lot of different meters, anywhere from hertz. My meter will actually measure microfarads and capacitance. We're not going to go through all of those. We're going to start with basic testing. And my basic testing is going to be DC volts. And that's going to be the voltage which has a straight line across it that represents direct current. From there, I've got an ohm scale. Now, my meter has the ability to do both ohms as well as diode testing. And we'll talk about diode testing in more advanced electronics classes, but that's the setting for measuring resistance in ohms. From there, I've got a higher current amp scale that you can see has both the AC signal and the DC signal. Remember, that's where we started. And then I have lower current scales as well that I can work from. Now, I kind of breezed over it. I didn't forget about it. Most of the time, what we're going to be measuring when we measure voltage is direct current. But there are times in certain sensors that I may need to measure AC voltage. And keep in mind, if I need to measure an AC voltage, I need to make sure my meter is set to the AC voltage scale. So where do we start? Let's start with voltage. What's the most simple and basic test? What I'd want to know is a battery fully charged. So put my meter over on the volt scale. I'd connect the red lead to the positive, the black lead to the negative, and I'd be able to tell the relative condition of a battery. If we flipped ourselves over and to measure resistance in the ohm scale, let's say, for example, I wanted to measure the resistance across the CAN bus lines, which we'll talk about again, more advanced classes, but just it's a simple test I can do at pin number 6 and pin number 14. And regardless of the vehicle, that should come out to be 60 ohms. If it's actually 0 ohms at that particular point, the CAN bus is shorted. If it's 120 ohms, one of the termination resistors is open. And again, we'll get into that in the more advanced classes. But what that OL means, that OL simply means it's out of limits. We've exceeded the range of this particular meter. Now, it could mean that the circuit is open, but if your meter is a manually functioning meter, where you actually have to set the resistance manually, or you have to push the range button to determine the range, at that particular point, make sure you've got the right scale. Also, you need to take a look once the measurement's made, whether there's any kind of suffix. In other words, did I measure 10 ohms? Or is there a K behind that that tells me, okay, hang on a minute here, that's 10,000 ohms, or possibly an M at 9.3, which is 9.3 million ohms. So always take a look at the suffix on your meter, as well as make sure you know where the decimal point is. Remember, when you're measuring resistance, always disconnect the car before you measure resistance. Possible circuit damage or damage to your meter could occur. So what's the next scale? Let's say I need to know how much current is it using. So for instance, I've got a 10 amp fuse. At that particular point, I know that's well within the range of my 10 amp meter. So I'm going to remove the fuse. When I remove the fuse, at that particular point, I'm going to replace the fuse with my meter. So all the current in this circuit is going to actually flow right through my meter. Now, I didn't have to do it at the fuse block. I could disconnect it at the component. As long as I'm running the current in series through my meter, I'll get to amperage measurement. Once I've confirmed that, what the actual current is, if I need to bring it down to a smaller scale, I'd simply shift my leads over to the smaller scale. Note to self, move the meter lead over to the 10 amp scale. So let's talk about voltage drop. Remember, we talked about the difference in potential voltage and voltage being used. Well, let's say, for example, I had 13.8 volts when I measured at the alternator, but only 13.4 volts at the battery. Well, Kirchhoff's law said if I put 13.8 volts in, all that has to be used, that means I've got to find that 4.4 volts someplace. So if I just wanted to measure how much voltage is being used between the battery plus terminal of the alternator and the battery, I'd connect the red lead to the most positive portion of the circuit, which would be the positive battery terminal. I connect my black lead to the most negative side, which in this case would be the battery plus side of the alternator. Now remember, voltage drop is only a valid test when current's flowing, which means if I'm going to do this test on an alternator, the vehicle has to be running. In the same way, I might measure the voltage drop across the positive and the negative battery cables to the starter. And again, if I was measuring the negative one, I'd put the negative lead, the negative post of the battery, the positive lead on the most positive section of the circuit. But remember, once again, my measurement's going to have to be made while I'm cranking the vehicle. Same thing holds true when I measured the positive side. I put my red lead on the positive post of the battery, my black lead on the starter solenoid, crank the vehicle, and you can see in this case, a half a volt was dropped across the positive battery cable, telling me either one, a bad cable, or two, simply a bad connection. To bring this all to life, let's do some actual tests. Now, the test we're going to do today, I'm actually going to do on components on a board to get you familiarized with your meter. As we get into some of these more advanced courses, we're going to start doing some of this testing actually at the class. So now that we've gone through the basic functions on our meter, let's summarize. Remember, a diagnostic is the result of multiple tests, and familiarity with your meter makes that testing simple. Remember, always disconnect the battery power before measuring resistance, and always remove your meter leads after testing circuit current. Hope this class has been helpful for you. Thank you, and please have a great day.